Imagine every computer, every smartphone, every satellite, every AI, every robot suddenly stopped existing. The internet disappears. Banks stop working. GPS vanishes. Hospitals lose their computers. Airplanes can no longer navigate. Your phone becomes nothing more than glass and metal. Now ask yourself, what one invention would you need to rebuild our entire civilization? Most people would say electricity. Some would say the computer. Others, the internet. They're all wrong. The answer is this: a transistor. A device smaller than a grain of sand, so small you could balance one on the tip of your finger. And yet, modern processors contain more than 100 billion of them. Without this tiny switch, there is no internet, no smartphones, no artificial intelligence, no modern medicine, no space exploration, no digital world. So, how can something so unbelievably small hold together an entire civilization? To answer that, we have to go back, not decades, but to the moment humans first tried to control electricity. Electricity is powerful. It lights our cities, moves our trains, runs our factories, powers our lives. But electricity has one frustrating habit. It never asks for permission. If a path exists, it flows. Like water running downhill. It doesn't think. It doesn't decide. It simply moves. Now imagine trying to build a computer using nothing but wires. Electricity enters, flows everywhere, and never stops. So how do you tell it, stop, go, turn left, turn right? You need a switch. The first switches were exactly what you'd expect. Two pieces of metal. Touch them together, electricity flows. Pull them apart, it stops. Simple, reliable, easy to understand. But imagine needing not one, not 1,000, not even 1 million. Imagine needing 100 billion inside something that fits inside your pocket. Mechanical switches are simply impossible. They're too large, too slow. They wear out. Humanity needed a completely different kind of switch, one with absolutely no moving parts. Remember silicon? In the last episode, we changed its personality. Sometimes it had too many electrons. We called that N-type. Sometimes it had too few. That's P-type. On their own, they aren't particularly interesting. But bring them together and something remarkable happens. Electrons from the N-type side immediately begin moving toward the P-type side. Why? Because they find something they've been looking for. Empty spaces. Holes. As electrons fill those holes, they leave behind positive charges. And where the electrons arrive, negative charges begin to build up. Very quickly, an invisible barrier begins to form, a tiny wall inside the silicon itself. This is called the depletion region. Think of it like two neighboring countries. Their borders were once completely open. Cars moved freely from one side to the other. Then, suddenly, the borders close. Traffic slows. Cars pile up. Eventually, almost nothing gets through. Electricity faces the same problem. The depletion region acts like a wall that blocks the flow of electrons. Interesting. Without even trying, we've accidentally created something that can stop electricity. But here's the real question. Can we control that invisible wall? Because if we can, we've just invented an electronic switch. Engineers had a crazy idea. What if, instead of touching the electricity directly, we controlled it without ever making contact? Not with moving parts, not with gears, not with metal switches, but with an electric field. Imagine standing next to a river. Instead of building a dam or placing anything in the water, you somehow change the river's path without touching it. Sounds impossible, but electric fields can do exactly that. Meet the MOSFET, the transistor that powers the modern world. At first, it looks simple, just 3 terminals: the source, the drain, and the gate. Forget those names for a moment. Think of them like this. The source is where the electrons begin their journey. The drain is where they want to go. And the gate isn't part of the road. It's the handle that controls whether the road exists at all. Right now, there is no path, no bridge, no connection. Electrons can't cross. The transistor is off. Now, watch carefully. We apply a tiny voltage to the gate. Here's the incredible part. Almost no current flows into the gate itself. It's not pushing electrons through. Instead, something invisible happens. The gate creates an electric field. That field reaches down through the insulating layer into the silicon below. Like an invisible hand, it begins rearranging millions of electrons. One by one, they gather beneath the gate, until suddenly they connect. A bridge, a conducting channel, a road that didn't exist just moments ago. Now, electrons rush across. Current begins to flow. Remove the voltage from the gate, and the bridge simply disappears. The road is gone. Current stops. The transistor is off again. That's it. That's the entire idea. A tiny voltage controls a much larger current. No gears, no motors, no moving parts. Just physics. Imagine just one transistor. Useful. Now 10. You can begin building simple electronic circuits. 1,000. Now you can perform calculations. 1,000,000. You have a calculator. 100 million. A smartphone. 10 billion. Artificial intelligence. Every single time your computer makes a decision, underneath, billions of tiny transistors are answering one simple question. Should electricity flow? Yes or no? Every photo, every video, every website, every game, every modern invention eventually becomes billions of microscopic switches turning on and off billions of times every single second. It's easy to look at a computer chip and see nothing more than metal, silicon, tiny lines, tiny rectangles. But hidden inside is humanity's greatest invention. Not because it's complicated, but because it's beautifully simple. One tiny voltage controls another. One switch becomes 2. 2 become 4. 4 become 8. 8 become 16, again and again, for decades. Eventually, you don't just build computers. You build the modern world. Inside every processor, billions of tiny switches work together. Not to think, not to understand, only to answer one question: on or off? The modern world isn't powered by electricity. It's powered by our ability to control it. Thanks for watching.